FastMCP introduces a declarative component registration system through standalone decorators, enabling loose coupling between tool implementations and server configuration. The framework's @tool decorator transforms ordinary Python functions into discoverable computational components without requiring explicit server instance binding. We are about to examine how a simple arithmetic operation gets exposed as a reusable tool component. The implementation will demonstrate the decorator's role in metadata preservation and type safety, while maintaining complete isolation from server initialization logic. From FastMCP Tools Import Tool. @tool. Def calculate summa, float b, float float. Add two numbers together. Return a plus b. This code demonstrates FastMCP3's standalone decorator pattern for tool registration, specifically using the @tool decorator to define an arithmetic operation. The calculateSum function is decorated with @tool, which marks it for automatic discovery by the file system provider, without requiring explicit server registration. This approach decouples tool definition from server configuration, enabling cleaner separation of concerns. The decorator pattern here serves two key purposes. It provides metadata about the function like the docstring description and registers it with FastMCP's component system. By using type hints a, float, b, float, and a return type annotation, float, the function gains self-documenting behavior that the framework can leverage for validation and documentation generation. The simplicity of this implementation, just a decorator and a pure function, makes it easy to test and maintain, though it does require the file system provider to be configured in the server setup. This pattern is particularly useful in larger projects, where you want to avoid circular imports between tool files and server configuration. However, it does introduce a convention-based discovery system that requires consistent file structure and naming. The trade-off is between explicit registration, more control, and automatic discovery, less boilerplate, with the latter being demonstrated here through the @tool decorator. Let's break it down line by line. From FastMCP Tools Import Tool. Imports the tool decorator from the FastMCP Tools module, enabling the creation of FastMCP-compatible tools with metadata and execution capabilities. @tool. Def calculate summa, float b, float float. Add two numbers together. Defines a function named calculateSum that takes two float parameters, a and b, and returns a float. The @tool decorator marks this function as a tool that can be invoked externally, and the docstring indicates it performs addition of the two input numbers. Return a plus b. Returns the sum of variables a and b. This is a basic arithmetic operation that adds the values of a and b and returns the result. The @tool decorator in FastMCP3 transforms a simple function into a discoverable component without tying it to server configuration. By decorating calculateSum, we leverage automatic discovery through the file system provider, eliminating the need for explicit registration. The decorator preserves metadata like the docstring and type hints, enabling self-documentation and validation while keeping the implementation clean and testable. This pattern trades explicit control for reduced boilerplate, making it ideal for larger projects where separation of concerns matters. The key insight is that the decorator handles both registration and metadata extraction, allowing the function to remain a pure, isolated unit of logic.
The decorator labels the function, but the sum returns itself, nameless, yet perfectly calculated.